Hello everyone, I wanted to take a few minutes to go through one more example of checking if a dataset is approximately normally distributed. So we said the main way to do this if I want to check if it's normally distributed is to look at the graph, right? So if I if I make the histogram here, I could check, okay, does this resemble a normal distribution? So in other words, is most of the data in the middle with a few lows and a few highs? Or is it skewed in either the positive or negative direction, where a lot of the values are either in the positive or the negative direction? So in class, we did the histogram by hand, just to get more practice with the boundaries and the tally and doing the histogram. But normally, to do it the quicker way, the calculator will do that for us. Because if you think about it, we're already putting this data in to calculate our algebraic method. So if you remember this formula from the end of class, so 3 times the mean minus the median over the standard deviation, right? So this is known as Pearsons Index. So this will give us a numerical way to look at whether it's positively or negatively skewed. But since we're already putting this data in to find the mean, median, standard deviation, the data is already in our calculator, so it will do the graph for us as well. So what we want to do here, so always put stat edit. You could see, throw your data in here. You can see we have 14 values I already inputted here, so go to the bottom list, we have 14 values. So once you have your data in here, under stat, you'll notice that there's a button above y equals called stat plot. So this is where you could plot the data from stat. So if you click on second stat plot, you'll see most of your plot should be off. So if we turn this first plot on, just click enter, turn it on. You can see that it does do a few. It'll do a scatter plot for you, line graphs. It'll even do block plots for you. We do it by hand because it's easy to do by hand, but and the axis is a little weird on here. But the histogram is here as well. So if you go over, mine's already selected. Select the histogram, and all our data is on L1. Right, so you can't enter out of here, but once you finish entering this, it'll save. So just click second quit. And notice when you go to y equals, and if you wanted to type a line or a parabola or something, notice that the plot one is selected, so that means it's on, so it's going to be plotting that. So if you want to turn it off, you could always do it from this menu as well. Just click up and deselect this, and then you can see if you go back to stat plot, it turned it off. If you want to plot other things, you're going to have to turn it off, but we'll turn it back on because we're going to be plotting our statistics here. Okay, so now it's on. So what we want to do, if you click on the graph, you won't see it because you'll have your normal axes, or if you change your window, your normal 10 by 10. If you want to see the histogram here, you have to click on the zoom button here. And this is where sometimes you might have used zoom trig or zoom decimal if you want to zoom in or out. What you want to do is go to option 9. So you scroll down. And once you do quicker here, once you get to this menu, you could just automatically click 9 rather than having to scroll down. But that's where it is. So zoom stat, so click on the 9 key. And you can see it zooms in to fit whatever data we inputted here. So you could see just by obviously looking at it, so it's very quick. It's obviously not normally distributed. So most of the data is on the left here with the tail. So it would look something like this with the tail getting flat over here in the positive direction. Right? Positive is to the right. So this would be positively skewed or right skewed. So most of the data is on the left here. So if I wanted to calculate Pearsons Index, so let's go to stat, go to our one variable statistics, enter, enter, enter. So let's calculate this. So I want to do 3 times the mean minus the median. So let's write this out here. So 3 times, okay, so the mean, so 976.35, so 976.357 minus the median. So we scroll down for our 5-number summary. So here's our 5 number, so 853.5. And then I want to divide that by the standard deviation, or S. So for the sample, so that's 376.2. 76.2. Okay, so if I calculate Pearson's index here, we said it was positively skewed since the tail was getting flat on the right or the positive side. So we should be expecting a positive number here. And we'll talk about that once we do this. So 976. You can round to the nearest 10th or 100th, but these were bigger numbers, so 5 and 7, so I just kept it for accuracy. So 853.5. Okay, and then we want to divide that number by 376.2. So Pearson's index here would be 0.9797 or about 0.98. Okay, so our general rule, if you remember, for Pearson's Index is that the closer it is to 0, the more normal it is. Because you remember, in a normal distribution, it should make sense, because in a normal distribution, we said the mean and the median were both located in the middle, right? So if the mean is equal to the median, well, something minus itself is 0, right? So 3 times 0 is 0. So if it's 0, it would be perfectly normal, because that means the mean and the median are the same. So the room we give ourselves is to 1 and -1. So as long as it's close to 0, so anything like 0.1, -0.1, 0.2 would be close to normal, or between 1 and -1. But you can see here, this is between 1 and -1, but it's pretty close to 1. So this is just sort of a general rule. It doesn't mean if it's between these two, it's absolutely normal. We want it more closer to like 0.3, 0.4, 0.5, the lower values. So even though this is between -1 and 1, we could clearly see from the histogram. That's why it's important to check on the histogram, because outliers could skew the data. It's clearly not normal. Okay, so even though it is, it's not normal. And since it's a positive number, we could say this is, and we already said it, but we could write this out. So this will be positively skewed. Okay, so if it could be like -0.8 or -0.9. So if this is the general rule, don't take it as absolute if it's less than 1. Because you see here, it's pretty close, but that's clearly not a normal distribution from our graph there. We had most of the values, so it would look something like this. Okay, so I want you to try this one. So input this data, check the histogram, and then calculate Pearson's Index. So what I want you to upload to Classroom is upload the Pearson's Index for this one, as well as a picture of the histogram. So take a picture of the calculator screen. So two attachments, so one with your work for this problem, and then one with the histogram screen. All right, that's all.